Well, hello everybody, and welcome to week 3, the second chapter that we're doing. This is compound interest and present value, chapter 12. As always, be sure to have this by Thursday midnight. Have your notes into me. Just show me the calculations, cover the basic concepts. Have your summaries be at least 150 to 200 words, and include examples from the beginning, middle, and end of the lecture, so that I know that you have watched the entire thing. I hope this is helpful to you. I hope that you have understood not only percents, but now that you've also understood simple interest before beginning to compound interest, because compound interest takes it one step further. So let's look at compound interest and what it means. Compound interest is the most common form. So when in simple interest, when I said, simple interest should be practical to you, you should understand what it should be in your daily life because you've used it. Well, that's even more true for compound interest, because in compound interest, the compound interest is the one that most facilities, most organizations, most institutions end up using. So let's skip over this. Let's look at some words first. Okay, compounding. That just means involves the calculation of interest periodically over the life of the loan or investment. That just means that we're going to be calculating interest not once at the end of the year, but we're going to do it at the end of every period, and we'll see what the difference is between the period and the year. Sometimes it's the same thing, but sometimes it isn't. And then compound interest is when you take that interest that you've calculated and you add it onto the principal. And then when you charge the next piece of interest, the next bit of interest, you charge it on this on the principal as well as the old interest, and it just gets bigger and bigger. So we'll show you an example of that in a little bit if that was a little confusing. And your future value is a compounded amount. It's the one at the end where you've added not only the principal but the interest on the interest, and if you have $1 today and if you compound it, what would it be worth in 5 years or at the end of those periods? That's the future value. That's what the goal is in this chapter, is we want to figure that out. And then the present value. If you have, I need to save up $20,000 in 4 years. What is the value of that $24,000 today? That's what present value is. That you've heard about inflation, that $1 today is not worth the same thing that $1 in a year or even 2 years, 20 years is going to be worth. So the future value is what is it going to be worth in 20 years. And present value is what is it worth today. So let's look at some other terms that we need to do before we actually calculate. So compounding annually. Annual, once a year. Okay? Semi-annual, every 6 months. So twice a year. Semi-annually. Semi means twice. Semi-annually, twice a year, every 6 months. Compounding quarterly. 4 times a year. Quarters are 4, right? And 4 times a year means every 3 months. Compounding monthly, of course, means every month, and that's 12 times a year. And compounding daily is every day. Hint, however, is that now we are not doing the exact interest like we did in simple interest. There's no simple and ordinary. We just say 1 year is 360 days. No 365. All institutions use the 360 term for their calculations, and so that's what we're going to be using. So remember to keep that in mind. So when it's compounded daily, it is 360 times. So let's look at what this means. Okay? So we have $1 today. After one period, the same dollar is worth $1.08. After 2 periods, that same dollar is now worth $1.17. And the future value at the end of the 4th year, it is $1.36. Now this could be a good thing or a bad thing. That means you had $1 today, you didn't do much to it, and that dollar is worth $1.36 in the future. That's a good thing. But it just means that whatever it costs $1 today is going to cost $1.36 in 4 periods as well. So you want to make sure, there's pros and cons to everything, so just understand that it is not the same. $1 in the beginning of the 1st year and $1 at the end of the 4th year, it changes and it grows. So how did we get these values? How do we calculate what this is worth? Well, Remember, this was, of course, at 8%, right? This dollar grew at 8%. So this is what they did. Simple interest in the beginning. So they have a dollar, they calculate 8%, which, remember, when we want to calculate percent, it is converted to a decimal. So 8% of a dollar is 8 cents. And so 8 cents plus a dollar is a dollar, and this is the maturity value. Remember, principal plus interest. Principal is 1, interest is 8 cents, and maturity value is now 1.08. Okay? Here's the difference between simple interest and compound interest. The maturity value of end of year 1, that becomes the new principal for year 2. So now we're calculating 8% at, it's not supposed to be times 0.10, it's supposed to be times 0.08. So that's supposed to be $1.08 times 8%, and you get the interest, which is 9 cents, and then you say $1.08 plus 9 cents, which is equal to $1.17, maturity value. Now your maturity value, again, for end of year 2 becomes your principal for year 3. And you just keep going until at the end of year 4, it's $1.36. Now this takes a really long time. Can you imagine if I would have said, you know, compounded monthly for 50 years? That would be 50 years compounded times 12, 50 times 12. That's a big number. So how can you calculate this? Well, before we do that, let's understand periods and rate, okay? The number of periods, remember when we said semi-annual, quarterly, monthly, daily? Well, if we have 1 year, how many periods do we have in that 1 year? That's what we need to calculate. We don't care about years, we care about periods. So say, for example, they tell us 4 years. Okay, if you compounded $100 for 4 years at 8% annually, semi-annually or quarterly, what is NNR? N is the number of periods, R is the rate. Okay, remember, N is the number of periods. It's not P, because P stands for percent, so you can't, that's very confusing. In this case, it would stand for present value. So just remember, N is the number of periods. So if it was annually, how many periods do we have in 4 years? Annually, 4 years is 4 periods. Okay, that's the easiest. But if it's compounded semi-annually for 4 years, it's 8 periods, because there are 2 periods for 1 year, 4 periods for 2 years, 6 periods for 3 years, and 8 periods for 4 years. Okay, so we multiply 4 by 2 because in each year there are 2 periods. And then, of course, quarterly. How many quarters are there in a year? 4. So 4 times 4, each of those 4 years times 4 quarters is equal to 16, right? So remember, I can't stress this enough. When doing your calculations, always make sure that you have the right number of periods. That's step number 1. Step number 2, if you're multiplying the number of periods, you have to divide the rate. So annually, it's 8 divided by 1, which is 8. Semi-annually is 8 divided by 2. So you multiply the periods by 2, but you divide the rate by 2. And quarterly, you times it by 4 for the periods, and you have to divide it by 4 for the rate. Here's why. If you just increased the number of periods, but you didn't change the rate, you'd be charging too much interest. Right? Think about it. If we would have just said 4 years at 8%, okay, let's make it quarterly. If we made it 16 and we kept it at 8%, now instead of 4 years, it's 16, and so they're just paying so much more interest. So to make sure that we compensate for the multiplication for the periods, we have to divide the interest, the rate, by the 4 as well. So for example, let's look at this. Simple versus compound interest. Bill Smith deposited $80 in savings in a savings account for 4 years at an annual interest rate of 8%. What is Bill's simple interest and maturity value? Now you know this. Interest is equal to principal times rate times time. Okay? Principal is $80. rate is 0.08 because it's 8% converted to a decimal, and time is 4 years. So the interest is equal to 25 and 60 cents. Maturity value is principal plus interest, which is 80 plus 25 and 60 cents. So that is now $105.60 at the end of 4 years. It's simple, it's easy. But look at compounded, right? This is a little more, it takes a lot longer, it's a little more complicated. So in year 1, we have our principal times our interest, times our interest rate, which is 80 times 0.08, which is equal to $6.40 interest, right? So we have our interest. What is our interest plus our principal, which is our beginning balance? And the end of the year is 86.40. So $6.40 of interest plus the principal, or the beginning value, which is $80, which is equal to 86.40. Remember, maturity value of year 1 becomes beginning balance, or the principal, of year 2. So then we calculate 8% of 86.4, which is equal to 6.91. Then we say 6.91 plus beginning balance, which is 86.4, and the end of the year balance is 93.31. Again, maturity value, end of year 2, is the beginning value, principal, of year 3. And we keep going so that the end of year 4, it's 108.83. Okay? So 108.83, also at 4 years, also at 8%, but look at the difference in the value, right? Both of them are $80, 4 years, 8%. But the reason why compound interest is more than the simple interest is because we've been adding the interest and we've been charging interest on the interest, right? And this is where interest can get a little dangerous if you don't take care of it. So now our interest, our total interest that we paid, 108 and 83, is our interest and our principal, which is our maturity value. So 108.83 is our maturity value. Subtract your principal and you'll get your interest. So you paid $28.83 $8 of interest versus 25 and 60 in the simple method. And so this is why, one of the reasons we tell you that if you're going to compound, say for example quarterly, and you multiply by 4, you have to divide by 4, otherwise your interest rate will be so much higher, it just doesn't make sense. It wouldn't be accurate. So, to make it easier, because, you know, like I said, imagine if I would have asked you to compound this monthly for 50 years. That would take forever. You would do, you know, 12 times for year 1, 12 times for year 2, and you would just keep going, and that would take too long. So there was, I forgot the guy's name. He sat down and he created this table, genius guy, so that every percent and every year you'd be able, and every period you'd be able to calculate what it would be. So it makes it a lot easier. So step number 1, to use this table lookup, which we'll go through the example. Step number 1, find the number of periods. Right? So if it's compounded quarterly, times it by 4. If it's compounded annually, times it by 1. If it's compounded semi-annually, times it by 2. Compounded monthly, times 12. And compounded daily times 365. Okay? Number 1, find the period. Number 2, find the rate, which is the annual rate that they've given you, divided by the same number that you multiplied step 1 in. So if you multiplied by 4 in step 1, you have to divide by 4 in step 2. If you multiplied by 12 in step 1, you have to divide by 12 in step 2. Step 3, look at the table. You'll have the rate and you'll have the number of periods. So you just want to make sure you get the ones that match. Look at it and you'll get your factor, your table factor. Okay? And then step number 4, really easy, the loan that they gave you, the dollar amount, the principal that they have, multiply that by the table factor, and this will give you the compound amount. Let's look at that. So they told us we had 4 periods at 8% for $80, right? So we go to 8%, we go to 4 periods, and we just make sure that they meet, and our table factor is 1.3605. Okay? Now our table factor, now that's what we got with step number 3. Now step number 4 is multiply 80, which was our dollar amount, times 1.3605. And if you multiply those two, you should have gotten the same value of 108 and some cents. Okay? So let's do a practice amount, a practice question. Pam Donahue deposits $8,000 in her savings account that pays 6% interest compounded quarterly. What will be the balance of her account at the end of 5 years? Step number 1, find the number of periods. We know it's 5 years compounded quarterly. Quarterly means 4. So it's 5 times 4, which is 20. Okay? Step number 2, right? Interest rate. If we times by 4 in step number 1, we have to divide by 4 in step number 2. So 6 divided by 4 is 1.5%. Okay? You go to your table. I wonder if this one has it. It does have it. You go to your table and you go to 1.5%. This one doesn't have the 20. You would keep going down. Do you see where it says period 1, 2, 3? You would go all the way down to 20 at 1.5 and then read that table factor, and you would get 1.3469. That's the table factor. And then step number 4 is you multiply that loan amount, that principal amount, which is $8,000. In this case, it's a deposit, times your table amount of 1.3469, which is equal to $10,775.20. Now this, what we just did, this number that we calculated, is what we got at the end of, if you see year 1, year 2, year 3, year 4, we had for 5 years, 4 quarters, so we had 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5 times. And that amount that we calculated of $10,775 was what we would have gotten at the end of our 20th period. So this just saved you so much time because you looked at the table. Now listen to me carefully. There are going to be some questions where, like, you said, well, what if the table in my book doesn't have the exact ones? If you look on My Course Connection, there's the Business Math textbook, but there's also the Business Math handbook, and that has your additional tables where you can look at 3.5, not just 3, and all those different types of percents and the periods that you need. Okay. So I hope that was easy enough to understand. If not, again, go back, rewind, listen to it again. Let me know if you have questions. Have questions ready for me for our live lecture on Thursday, and we will take care of it. So nominal and effective rates, which is called your APY. What does that mean? So your nominal rate is the rate that they calculate the business, the interest that we use in our calculations. Okay, that's the nominal rates. That's what they've stated. And your APY, your annual percentage yield, is what did you actually end up paying. And because we're compounding, because we're charging interest on interest, at the end you'll notice that you end up paying more interest than they actually tell you for the nominal rate. So again, when somebody makes you sign something with the fine print of the interest rate, you want to be careful to see what it is, because you might end up paying more interest because it's compounded. Let me show you an example. So, by the way, the way you calculate your API is the interest that you were charged divided by the principal. That's a by the way. So, for example, we have 8% compounded quarterly. And so let's just take 1 year for now, okay? So compounded quarterly, what does that mean? Periods, 1 year, 4 quarters, which is to 4 periods. Percent, we multiplied by 4 for the periods, so we have to divide by 4 for the rate or for the percent. So 8 divided by 4 is 2%. Principal is $8,000. Okay, so now we look at the table. We look at the period, which is 4. We look at the percent, which is 2. Go to the 4. I hope this one has it. 4%, 4 periods, 2%, which is 1.0824. Look down the column where it says 2% and look across where it says 4 periods, and you'll get 1.0824. So let's go back. So now we know that it's 1.0824, so we multiplied by 8,000, and so we get $8,659.20. That is our total interest compounded over the 4 periods and at the end of the year. So it is our interest plus our principal. It is our maturity value. And to get the actual interest amount, we have to subtract the principal, which was 8,000, and we know that the interest that we paid was $659.20. Okay, so $659.20 was the interest that we paid over those 4 quarters, over those 4 periods. But now let's calculate the effective rate, the APY. So you take your interest divided by your principal, which is $659.20 divided by 8,000, and we get 0.0824, which to convert from a decimal to a percent, you have to move 2 places to the right. So now it's 8.24%. But didn't they tell us it was 8% interest? Yes, it was. That 8% was the nominal rate, the stated rate that they told you, and that's what they used to calculate the interest. But because we're paying interest on interest, we add the interest to the principal, then we charge new interest. Then we add the interest to the principal, and we add new interest. We ended up actually, instead of paying 8%, we ended up paying 8.24%. Okay? And that's if we were compounding it quarterly. What if we were to do the same thing and compound it semi-annually? So how many periods would we have? Semi-annual, twice a year, so we times it by 2. So 1 times 2 is 2. Percent, or the rate, because we multiplied by 2 in periods, we have to divide by 2 in percent, so we get 4%. Our principal is still $8,000. We go back to our table and we look up 2 periods, 4%. Last time we looked up 4 periods and 2%. Now we're going to look up 2 periods and 4%, which is very different. So now it's going to be go across on the 2 periods and come down on the 4%, and you will see 1.0816. So we get 1.0816, multiply it by our principal, which is step number 3, and we get $8,652.80. Minus our principal to get our total interest amount, just our interest, not our interest and our principal, and our interest is $652.80. Now, how do we figure out our effective rate, or our APY? We say our interest divided by our principal, so 652.8 divided by 8,000, and we get 0.0816. That is the decimal we want to convert it to percent. So we convert it by moving the decimal point 2 places to the right, so it becomes 8.16%. Okay? Same principal of 8,000, same nominal interest rate of 8%, and different periods, and it can show you the difference in the effective interest rate. So basically what they're saying, at the end of 1 year, if you were to compound it semi-annually, you would pay 8.16% of interest. But that same amount, if you were to compound it quarterly, you would pay 8.24%. So the more you compound it, the higher your interest rate is. Okay? Remember, this is still 1 year. Same time, but it's a different number of periods because of how frequently we compound it. So this just means if you're from January to December, you compounded it quarterly in March, in June, in September, and in December. But when you're compounding it semi-annually, you compound it so you deposit it in January, you compound in June, and again you compound in December, and that's why the interest is lower. The more you compound, the higher the interest will go. So let's take a look at this in the big picture. So beginning balance, we have $1,000. The nominal interest rate stays the same, 6%. Okay? But now let's look at the 4 different ways of compounding it: annual, semi-annual, quarterly, and daily. Okay, we didn't do monthly in this one, but that's okay. The end balance, looking at the rate, because remember, annual we times by 1 and divide by 1, the periods and the rate. Semi-annual, we times by 2, divided by 2, periods and rate. Quarterly, times by 4, divided by 4, periods and rate. So you times the period by 4, divide the rate by 4. Daily, times by 360, the periods, divide by 360 for the rate. Okay? So if you were to get those percents and you would look it up in the table, your end balance, and then you would multiply that, of course, the table factor, you would multiply to that 1,000. You would get 1,060, 1,060 and 90 cents in semi-annual, 1,061 and 36 cents quarterly, and 1,062 and 70 cents for daily. So if you notice, your ending balance gets more. It's 1 year. It's always 1 year. It's did we compound it once, did we compound it twice, did we compound it 4 times, or did we compound it 360 times, right? And that's what changes the ending balance, what makes it go up. Again, take the interest, divide it by the beginning balance, and you'll get your effective rate, or your APY, and you'll see your rate goes up as the more frequently that you compound it. So 6%, same amount of money, same time of 1 year, compounded more times, it becomes 6.09, 6.14, and 6.18%. So I hope this kind of clarifies for you that your ending balance, which is basically your interest, is going up, and your interest rate is going up effectively as well. So let's do check out this other table. So if you were to compound interest daily, table 12.2 in your book, right? 6% after 1 day would at $1 at the end of 1 day would be $1.06. $1 after 4 periods, so you look at period 4, 6%, it would be 1.2712. If you were to round that for $1, it would be $1.27, $1.27 instead of at the end of 4 days. Here's the thing though, when you are calculating, there's a reason that it has been carried out the decimals to 4 places. When you're multiplying your table factor to your principal amount, don't round until the very end, because these decimals are very, very important, and they can make or break your equation. So, compound interest daily. Use table 12.2 to calculate what 1,500 compounded daily for 5 years will grow to at 7%. So our number of periods is 5, and our rate is 7%. Now here's the thing, because this is compounded daily, we already know that the periods are in years. That's what it seems like. This is a bit confusing, that the way they have set it up. So we go 5 periods, 7%, which is 1.4190, and so this seems to be incorrect, but this is the way that they have set it up in the textbook. So $1,500 times 1.4190 is equal to $2,128.50. Okay. So now let's look at if we were to do it the opposite. What we did now is we have $1 now, or we put savings now. What will we have in the future? Okay, what we want to do now is we have the future value. How do we calculate the present value? I know that in 4 years I'll have $1, but what do I have to have now for that to become $1 in 4 years? So same thing, find the number of periods, find the rate, just look at a different table. Make sure that you're looking at the right table and that you're trying to calculate the present value at the table. Multiply the table factor by the future value, the one that you're going to have at the end, and this will be your present value. So we know that it's going to be 4 periods at 8%. So it's going to be, the table factor is 0.7350. Okay? If you go down the 8 and go across the 4 periods, and you'll see 0.7350. So now we get that table factor and we multiply it to our dollar value, and we will find out what our present value is. So let's say, for example, take note of this now for your homework. Compound value. So if you have your present value and you want to find the future value, the compound value at the end of some periods in the future, you look at table 12.1. If you want to you have the future value and you want to compound, what would that be worth today? You would look at table 12.3. It can make or break you. If you look at the wrong table, you'll be doing the wrong thing and you'll be getting the wrong number. So pay attention, make sure you know which table to be using. So we have 4 periods and we have 8%, and our principal is $80. Okay? So we know we have $80 today. What we've been doing this whole time, we have 4 periods, 8%, get the table value. So our $80 today at the end of 4 years is worth $108.84. Okay? But now, what if they would have given us $108.84 and said, in 4 years, I want $108.84. What should I invest today so that when it grows at 8%, I will have $108.80? So now you go to table 12.3. Again, number of periods, 4. Interest rate is 8, and you get that table factor, and you get 0.7350. Multiply that, and you'll get 80, which is the present value. Okay? So in the compound value table, we know the present dollar, and we want to find what the dollar amount is in the future. But in the present value table 12.3, we know the future value, and we want to find what is the dollar amount in the present. So for example, Renee Weaver needs $20,000 for college in 4 years. She can earn 8% compounded quarterly at her bank. How much must Renee deposit in the beginning of the year to have $20,000 in 4 years? So she needs $20,000 in 4 years. What does she need to do today, knowing that she's going to be going in 4 years? She has a time, she has number of periods, and she knows she's going to be earning 8% quarterly at her bank. Okay? We follow the same steps. Number 1, find the number of periods. 4 years compounded quarterly. Quarterly means times 4. 4 times 4 is 16. Okay? Rate. If we times by 4, we have to divide by 4 for the rate. So we have 8% divided by 4, which is 2%. So we look up on our table 12.3, we're going to look up 16 periods and 2%, and we're going to get a table factor of 0.7284. That's step number 3. Step number 4 is compound the, you want to multiply the amount. So you have your 20,000, multiply that by your table value, and you'll get 14,568. So that just means that if she wants to have 20,000 in 4 years, today she needs to invest 14,568 so that when it gets 8% every quarter, she will have that 20,000 at the end of 4 years. So that was the last slide for this chapter. Again, if you have any questions, please let me know. If this is starting to get a little more challenging for you, just set a time with me and I will help you. We can do similar problems together so that you can do better on your homework assignments. As always, make sure that it's on time so that you don't lose any unnecessary points, and keep watching these videos. This is easy credit. You just type up what you've learned, type up your questions if you still don't understand something, and then that'll at least give you your other credits so that it can raise your assignment if you haven't done so well in the past and you want to do well. Don't forget, again, always do your discussion posts, because that again is free points. You can just boost your grade. Other than that, I hope you guys have a wonderful week, and as always, let me know if you have questions. This assignment is due by Thursday night at midnight, and don't forget, we will see you on Thursday for our live lecture.